You can start now, sir.
All right. So, good afternoon, students, and welcome to the second live interactive session on integral and vector calculus. So, I have got some questions from some of you. So, the first question is, how is it helpful in a broader aspect in career choosing? Well, this is not course relevant. So I would advise to ask questions related to integral and vector calculus. Now, how is it helpful? Basically, you need vector calculus in almost a lot of applied mathematical subjects. So, for example, in mechanics, in fluid mechanics, continuum mechanics, there, if you want to write equation of motion of a certain fluid particle, you basically need vector calculus, or at least some knowledge of vector analysis in order to write the equation of motion. Vector calculus have a lot of applications. Integral calculus have a lot of applications, and I would advise you to look into some basic mechanics books like fluid mechanics or say continuum mechanics books. What is the future aspect? What are the future aspects? Well, the future aspects is that I believe you are still in your first year or second year, because it is actually a first year or second year preliminary course that we offer in our institute. So in future, if you're from mathematics background, you can further widen your interest towards partial differential equations, then subjects like mathematical modeling, asymptotic analysis, homogenization theory, micro macro scale modeling. And from there, you can probably choose to go into the research where you can work with problems from fluid dynamics, from flow in porous media, material sciences, and chemical engineering, things like that. So problems from engineering sciences and life sciences, they are also governed heavily by mathematical equations, and there you need vector analysis, integral calculus up to some extent to analyze and solve those problems. Next question is waiting for the lecture to complete. We'll ask after. Okay, I don't know yet what questions I asked and no question. What is the application? Well, application of integral calculus and vector calculus, that's what I have been trying to tell you, that it has a lot of applications. So as I was telling you, if you want to write a motion of a fluid particle, let's say you have a certain fluid flow in a closed region, and if you want to write the equation of motion of that fluid particle, you need the velocity vector, you need how to say the pressure and the density, and combining all these ingredients, you can be able to write down the equation of motion of a certain fluid particle. Or if you are analyzing a transport processes in a certain given region, then in that case, you can write down the diffusion reaction equations of chemical species, the transport processes that actually govern those phenomena in a porous medium. So there are a whole lot of applications in applied mathematics, not just one and two. It's just that if I try to explain you now, it will be a little bit an advanced level discussion. So if you are still in your first year or second year, I would heavily advise you that after you finish this course, integral and vector calculus, you should take courses such as partial differential equations, as many courses as you can, transform calculus, continuum mechanics, fluid mechanics, mathematical modeling, mathematical biology. And the more you take these kind of courses, you will see a whole lot of applications of integral and vector calculus. So don't just think that this is just completing a course. You pick any branch of applied mathematics, there you will find some things related to vector calculus, integral calculus, and things like that. Okay. How integral calculus came into being? Oh, I'm not answering these philosophical questions. The requirement is vector calculus. The requirements in vector calculus and chemistry. Yeah, there will be some requirements when you are writing the transport processes of chemical species in a certain domain. There, you need to write down this diffusive how to say this flux, how it is flowing. We know that it flows from region of higher concentration to lower concentration. So you can be able to write this using a fixed law, which is nothing but minus of k times gradient of u, where k is the diffusion coefficient. So there you have a small application of vector calculus there. So there are a lot of such situations. Can you please tell something about vector calculus identities? Well, you use them to simplify certain equations. I mean, it's not that there is one particular identity which can be used in a certain situation. There are hundreds of different types of vector identities, and you use them based on your requirement. Importance of vector calculus in theoretical statistics and probability theory. Well, I don't know how vector calculus is applied to statistics and probability theory. Because I'm not a statistician, but I haven't come across in probability where we talk about vector calculus. So I don't know. Any further questions? I would appreciate if you ask me questions related to the topic and not philosophical questions, because for that you have to research on your own. All right. If you have any questions related to the course, that would be good. Okay, because you're where we talk about vector calculus. So I don't know. Any further questions? I would appreciate if you ask me questions related to the topic and not philosophical questions, because for that you have to research on your own. All right. If you have any questions related to the course, that would be good. Okay, because where we talk about vector calculus. So I don't know. Any further questions? I would appreciate if you ask me questions related to the topic and not philosophical questions, because for that you have to research on your own. All right. Yeah, what is your question? Integrals related. First of all, ask in English. Let's abide by the platform rule. So let's stay common language. I mean, let's try to communicate in English. And what is your question related to integral calculus? Yeah, what is your question? Integrals related. First of all, ask in English. Let's abide by the platform. So let's stay common language. I mean, let's try to communicate in English. And what is your question related to integral calculus? Yeah, what is your question? Integrals related. First of all, let's abide by the platform. So let's stay common language. Let's try to communicate in English. And what is your question related to integral calculus? Yeah, what is your question? Integrals. Yeah, good afternoon to everyone. Yeah, good afternoon. Yeah, good afternoon. No, there is no some valuable formula. So, first of all, in mathematics, if you are thinking that learning about some formulas and some tricks that will help you in the competitive exams, that's not a good mentality. So, I myself, being a mathematician, I do not believe on those things. So, if you find some small formulas that will help in competitive exams, good for you. But I'm not going to suggest you any such formulas. Some valuable formulas. So, first of all, in mathematics, if you're thinking that learning about some formulas and some tricks that will help in the competitive exams, that's not a good mentality. So, I myself, being a mathematician, do not believe on those things. If you find some small formulas that will help you, good for you. But I'm not going to suggest you any such formulas. So, what is it about? Revolution integration? Tell me. That's not a good mentality. So, I myself, find some but what is it about? Revolution integration? Good afternoon. Do you have any questions? Good afternoon. Do you have any questions? Yeah, good afternoon to all. If you have any questions, just type your question or put it in that Excel sheet which was circulated to you. Yeah, good afternoon to all. If you have any questions, just type your question or put it in that Excel sheet which was circulated to you. Yeah, good afternoon to all. If you have any questions, just type your question in the Excel sheet which was circulated to you. What is it? What do you want to know from integral? You have to type your question. What is it that you want to know? What is it? What do you want to know from integral? You have to type your question. What is it that you want? From integral, you have to type. Revolution integration. I'm guessing you meant integral, that revolution of surfaces, right? So I'm assuming that that's what you mean. So basically, the revolution of surfaces when we calculate the volume by rotating a surface around a certain axis. So you can think of one basic example is you can think of a semicircle, let's say, and if you are rotating around x-axis, so basically it will generate a sphere, right? So if you have a, I would say this more like semi-disc or half of the circular disc, and if you rotate it around the x-axis, then basically what will happen is you generate a sphere, and you can write down the surface area of that sphere using that surface area formula, which was given into the class. And this is how you can think of how a surface can be generated using this using this revolution of a certain curve around a certain axis, right? Similarly, if we rotate a parabola around x-axis or around y-axis, let's say, then in that case you can generate a paraboloid kind of structure. So that is another example where you have a surface revolution and you generate a paraboloid. And we can talk about its surface area, we can talk about its volume and things like that. All right. If you rotate, I'm going to put on my headphone. I think there is some echo. Why? That can generate parallel. All right. So as I was saying, that surface of revolution is something you can think of it as you have a semi disk, semicircle, which is like a we have basically a disk, half of the circular disk. And if you rotate it around x-axis, so you can visualize the picture. We are rotating it around the x-axis, and that will sort of create a sphere, right? So because of this revolution around the x-axis, we are creating a sphere. We can talk about its surface area, we can talk about its volume, and there are formulas to calculate the surface area and calculate the volume using this revolution, right? So similarly, we can rotate different types of curve around a certain axis, and that will generate a surface whose surface area or volume we can talk about. All right. And there are formulas. Any other questions? All right. I think they don't have any further questions, so maybe we should close the sessions. I'm not seeing any questions in the chat box, and also no questions in the Excel interactive um, web session. So gradient in vector is basically when you have a gradient operator. I usually prefer to call it nabla. So first of all, you cannot say gradient of a vector. So when we have a vector and if you want to charge nabla onto it, you can do the charging via two ways. Either you can charge it via dot product or you can charge it via cross product. So we have a vector function, let's say fx, and if you're charging nabla, which is also a vector quantity, so that vector and vector, when you are writing one vector next to another, it has to make sense from mathematics point of view. So it has to be mathematically defined, well defined, and therefore we can charge the nabla operator on a vector function f via two ways. Either you can do the dot product or you can do the cross product. But if you have a scalar function, then it will be just gradient of that scalar function, which is what we call grad f. Okay, so if you have a vector function, then it is either a dot product or cross product. And when you have a scalar function, so when you have a vector function, then it is either a dot product or cross product. And when you have a scalar function, then it is usually the gradient of it. Okay. Any other questions?
Sir, you can conclude the session if you want.
Yeah, that's what I was saying. All right. So if you don't have any further questions, then I will stop here, and I will see you in the next live session, which is next week. And I would advise you to ask questions related to the topic, not philosophical questions. All right. So I'll see you all next week, and that's it from my side. So can I just leave the meeting or end it, or what should I do?
Leave, sir.
Leave.